Welcome back to the deep dive. Today, we are staring at a stack of documents that, frankly, looks a little bit like a paradox.
It really does.
On one hand, we have some of the most advanced, bleeding-edge cybersecurity concepts I have ever seen. I mean, things like Xyber Logik and generative evidence forges.
It absolutely sounds like science fiction.
But on the other hand, the application of all this tech is incredibly, well, grounded. It's almost mundane.
Right. It's a collision of high-concept computer science and very low-level bureaucratic reality.
Exactly. It's all about a pilot program in Sacramento, California, set to launch in February 2026, aimed at nonprofits and state agencies.
Not exactly the futuristic setting you'd imagine for this kind of tech.
Not at all. And the central theme here is something we talk about a lot but rarely seem to solve. Trust. Or maybe the crisis of trust in the digital age. But before we get into the universal trust fabric, which is the subject of our deep dive today, I want to ask you something.
Go for it.
When someone sends you a security compliance report, usually a big PDF, do you actually read it? Or do you just file it?
Oh, that's the crisis of trust right there in that one question.
Right.
In the industry, we call that asserted trust. You send me a PDF that says, I promise I am secure, or, I promise I followed the protocol.
And I'm just supposed to believe you.
You're supposed to believe me because the document looks professional. Maybe it has a nice logo. But does that PDF actually prove anything?
No, of course not.
No. It's a snapshot in time. It's a claim, not evidence. It's a nicely formatted promise.
It's a slide deck that just says, trust me.
Precisely.
And the source material we're covering today, specifically around this OHID project, which stands for Outer Haven Inner Daemon, it argues that trust me is dead.
Or at least it should be. The new model has to be verify me.
Verify me. I like that. That's the shift.
That's the whole shift. We're moving from a world where trust is based on reputation or these static documents to a world where trust is discovered, verified, and repeated using cryptographic proofs.
So it's about math, not just promises.
Exactly. The goal of OHID isn't to just say we are secure, but to mathematically prove we behaved correctly in a way that an auditor or even a piece of software can instantly verify.
Okay, so our mission today is to unpack this specific project, OHID. We've got a technical demo, it's version 4.2.
Yep.
We have a strategic rollout plan for the 916 area code, which is Sacramento.
The ground level stuff.
And a very, very dense architectural breakdown. But I want to start with the name because it feels heavy. Outer Haven Inner Daemon.
It sounds like a metal band.
It does. Or maybe a philosophy textbook. What are we actually looking at here?
It is a bit dramatic, isn't it? But the name is actually a very precise description of the architecture.
Okay, break it down for me.
Outer Haven refers to the protected space. In security, we talk about perimeters, firewalls, air gaps, all that. That's the haven.
The castle walls, you want to keep the bad stuff out.
Right, the castle walls. But walls are never enough. Once you're inside the walls, how do I know you're behaving correctly?
That's the second part.
That is the inner daemon. And for the non-programmers listening, daemon here doesn't mean a demon from hell.
Right, it's an old tech term.
It's an old Unix term, DAEMON, for a background process, a program that runs silently in the background, just waiting to handle requests or monitor systems.
So it's not a ghost, it's a watcher, a silent guardian.
Exactly. The inner daemon is the governance layer. It's the internal monitor that watches every single decision made inside the haven.
So you have the walls, and you have the guard inside the walls.
Perfect analogy.
Yeah.
And the core philosophy here is that OHID is a trust governance system. And I really need to stress this distinction because it's so important.
All right.
This is not a firewall. It is not an antivirus.
Wait, hold on. Let me stop you there. If it's not a firewall and it's not an antivirus, what am I buying? If I'm a chief information security officer, a CISO, and you pitch me a trust fabric, but it doesn't block hackers, why do I care?
Because your firewall blocks the hacker, but it doesn't prove to your board of directors that the hacker was blocked or that the person who configured the firewall did correctly.
Okay. It's the proof layer.
It's the proof. Security tools do the work. Trust governance proves the work was done. It is the difference between a police officer making an arrest
And the body cam footage.
and the body cam footage that proves the arrest was legal. OHID is the body cam, the court stenographer, and the evidence locker, all rolled into one system.
Okay, that makes so much more sense. It's the layer of accountability that sits on top of everything else.
You got it.
So let's look at the demo context from the sources. We have a document here, trust package PowerShell demo.pdf. It looks like this whole massive thing started as just a simple script.
It did. It began its life as trust-demo.ps1, a simple PowerShell script that just scanned files and checked their integrity. Very, very basic stuff. But the iteration we're analyzing, v4.2, has evolved into a universal trust fabric. It's now a React and Node.js application that runs entirely in the browser.
In the browser.
In the browser.
Mm-hmm.
But here's the trick. It's simulating a massive, distributed back-end ecosystem. It's giving you the full experience without the setup.
And they visualize this ecosystem in a way that I found really striking. The notes mention a 3D fabric visualization using WebGL.
Yes. This is one of the coolest parts. Instead of looking at rows and rows of text in a log file,
Which no one wants to do.
which is mind-numbing,
Right.
the system renders a 3D space. You see nodes, which are like servers or databases. You see connections between them, which are called edges.
And you see animated replicants.
Right.
Again, with the sci-fi naming, I'm assuming these aren't synthetic humans running around my network.
No, sadly not. That would be cooler. In this context, a replicant is just a visual avatar for an actor in the system.
So it could be me, a user.
It could be you, it could be a bot, it could be an automated process. And you actually see these little replicant avatars moving between the nodes. If a user accesses a database, you see their replicant travel along that edge to that node.
So it creates a spatial understanding of what's actually happening.
Precisely. It turns abstract data into a tangible spatial reality. If you're an auditor, what would you rather do? Read 10,000 lines of user X access node Y at this timestamp.
Or look at a 3D map and see a swarm of red dots attacking a specific server.
Exactly. You can see the trust relationships and you can see when they're violated.
Okay, so that covers the outer haven visual. It's the map of the castle. But I want to drill down into the inner demon.
The architecture of truth.
The architecture of truth. The source material makes a really big deal about the ledger, but it says it's a client-side ledger stored in local storage.
Mm-hmm.
Now, for the tech-savvy listeners, isn't that, well, bad? Local storage is just a browser cache. I can go in and clear that out with 2 clicks.
You are absolutely right to be skeptical there, 100%. In a real production environment, relying solely on local storage would be a disaster.
Okay, so what's the deal?
Remember, this is the demo version, v4.2.
Mm-hmm.
They are simulating the experience of a distributed ledger without requiring you to spin up a whole blockchain node just to see a demo.
So the storage is temporary, but the mechanism is real.
The mechanism, the cryptography, that's real. The storage is a placeholder for the demo.
Mm-hmm.
But the math is permanent.
Okay, so what kind of math are we talking about? The notes highlight ED25519 key pairs.
Right.
Why that specific algorithm? Why not the RSA keys we've been using for like 20 years?
That's a great question, and it's a very deliberate design choice. RSA keys they're big, they're heavy, and they're computationally expensive to generate and sign with.
They're slow.
They're slow. ED25519 is an Edwards curve digital signature algorithm. It is incredibly fast. The keys are tiny, just 32 bytes, and it's designed from the ground up to be secure against side channel attacks.
So it's built for speed and a modern architecture.
Exactly. If you want a system where every single action, every mouse click, every approval, every file access is cryptographically signed.
You can't have a lag.
You cannot use slow, clunky keys. You need something that can fire off signatures in milliseconds without the browser even noticing.
ED25519 allows for that kind of high-frequency signing.
So every time I do anything at all in this trust fabric, I am leaving a permanent mathematical fingerprint.
Yes. You're not just doing something, you are minting an event.
Huh.
And this leads to the next critical piece, the chain of custody.
Okay.
The ledger functions just like a blockchain. Each new entry contains a cryptographic hash of the previous entry.
The classic blockchain link. Each block is chained to the one before it.
Right. So let's play this out. Let's say on Tuesday you approve a budget. On Wednesday you realize that was a huge mistake, so you try to go into the database and just delete Tuesday's entry.
Can't do it.
You can't.
Because Wednesday's hash depends on Tuesday's data. If I change Tuesday, the math for Wednesday doesn't work anymore. The moment you touch Tuesday's data, Wednesday's hash becomes invalid. The chain breaks. The demo actually has a chain integrity indicator right in the UI. If you mess with the history, it turns bright red. It basically screams tampered at you.
So it creates a history that is mathematically tamper-evident. You can't rewrite the past without everyone knowing.
Which brings us to identity. In most systems today, identity is just, user, Bob, password, password 123. If you have the password, you're Bob.
And Bob can do whatever Bob is allowed to do.
Right. In full-tide, identity is treated as an artifact. They have a module called the identity minter. You don't just create an account.
You mint an identity.
You mint an identity that consists of a set of signed attributes, your name, your role, your mission scope, what you're allowed to work on. And this identity artifact is placed in a registry of public keys.
It sounds more like issuing a passport rather than just printing a name tag.
That is a great analogy. A name tag, anyone can write on it. The passport has watermarks, holograms, and it's issued by a trusted authority. In OID, your identity is a governance artifact.
So it's distinct from simple authentication.
Totally distinct.
Yeah.
The system doesn't just ask, do you know the password? It asks, where is your signed passport, who issued it, and has it been revoked in the official registry?
Okay, I think I've got the foundation now. We have this tamper-proof ledger and these passport-grade identities, but now let's talk about what this thing actually does.
The fun stuff.
The killer features section of the outline. And honestly, some of this sounds like wild overkill. Let's start with the AI. Everyone has an AI feature now. What makes the decision engine here any different?
The problem with AI and security today is what's called the black box problem.
Right.
An AI looks at a network packet and says, block it. And you ask why. And it says, because I said so. That is not acceptable for an auditor. You cannot audit vibes.
You can't audit a gut feeling from a machine. Computer says no.
Exactly. So OHID introduces an explainable AI module. It uses two really clever tools to break open that black box. First, there's the logic diff viewer.
A diff viewer, like for code.
Just like for code. Imagine the AI changes its mind about what it considers safe. The logic diff viewer compares the decision tree from yesterday against the decision tree from today, and it highlights line by line exactly what logic changed.
So I can see, oh, okay. The AI has now decided that traffic from this specific IP address is now considered risky.
Yes. You see the logic shift. And then there is the second tool, the Rationale Explorer. This lets you click on any specific decision the AI made and trace the path it took.
So it shows its work.
It shows its work. I blocked this because of condition A, which led to condition B, which ultimately triggered rule C. It's a full auditable explanation.
But the notes say the AI is advisory only. Why build all this complex, explainable AI if you aren't going to let it actually pull the trigger on a decision?
This is a really important philosophical stance on trust governance. If an AI makes a mistake and deletes the production database, who do you sue?
Right. You can't sue an algorithm.
You can't. So OHIDing enforces a human-in-the-loop requirement for all critical decisions. The AI provides the recommendation. It even gives a confidence score. But a human must be the one to sign the final decision.
And because of the immutable ledger,
that human signature is recorded forever on the chain. Admin Sarah approved this action at this time based on this AI advice. Accountability remains biological. You cannot hide behind the machine.
I really respect that. It forces people to actually own their security posture. Okay, next feature, mission replay. The notes call it the DVR of security.
This is one of those features that sounds simple, but it completely changes everything for an auditor or an incident responder. Usually when something bad happens, your response involves reading log files.
Thousands and thousands of lines of text.
It's boring, it's tedious, and it's incredibly prone to error. You miss things.
So what does mission replay do?
It lets you scrub through a timeline of an incident, just like a video player. You watch the replicants moving around the 3D map. You see the alerts fire in real time. You see the human responder make a decision.
It's visual.
It's visual. And crucially, it links the specific decision to the closure evidence. You see the problem and then you see the fix, all in one continuous replayable mission.
Okay, visual replays I can get behind. That makes sense. But this next one, I have to push back on this a little bit.
I think I know which one you mean.
The evidence forge. The notes say it uses generative AI, specifically Google's Gemini and Veo APIs, to produce cinematic reenactments of security incidents.
Yes, it does.
A movie? We are making a movie of a cyber attack. Come on, that sounds like absolute vaporware. Why would any serious security professional want a Hollywood dramatization of a SQL injection?
I had the exact same reaction when I first read it. I thought, is this just a gimmick?
It sounds like one.
It does. But then I thought about who the customer of this evidence actually is. It's not always the engineer. Often it's the board of directors. It's the CEO. For the target audience in Sacramento, it's a non-technical donor for an NGO.
So it's for people who don't know what a SQL injection is?
Exactly. If you go into a board meeting and say, we successfully mitigated a persistent cross-site scripting vulnerability on port 443, their eyes just glaze over.
You've lost them.
You've lost them completely. But if you show them a 30-second generated video, a cinematic reenactment that visually demonstrates an attacker trying to breach the castle wall and the system stopping them, you have instantly communicated value.
So it's a translation layer. It's translating technical gobbledygook into a narrative that a human can understand.
Yes, and here's the critical part that makes it not a gimmick. The inputs for that video, the prompt, the log data, the parameters, are all signed and hashed on the ledger alongside the final video.
So you can prove the movie wasn't just fiction.
You can prove it's a faithful, verifiable representation of the raw data. It's what you could call verified storytelling.
Verified storytelling. I suppose that is useful. It's taking explainable AI to its logical extreme. Explain it to me like I'm 5, but with, high production value. Okay. The last big tech feature here is adaptive resilience. This involves something called a PPO reinforcement learning loop. I know we want to avoid jargon, but we have to unpack that. What is PPO?
PPO stands for Proximal Policy Optimization. It's a standard and actually very effective reinforcement learning algorithm. It's the kind of algorithm you'd use to teach an AI how to play a video game, for example.
Okay, so it learns from trial and error.
Right. You reward it for good moves, you punish it for bad ones, and over time it gets better.
So in this context, the game is keeping the network secure.
Correct. The system uses this PPO loop to constantly adjust its own internal weights, things like threat filters or its sensitivity to certain types of traffic.
So it learns what's normal for my network.
Exactly. Maybe it learns that on Friday afternoons, there's always a huge traffic spike because everyone is backing up their work. So it learns not to trigger a high-volume alert at that specific time. It updates its own internal logic based on observation.
But again, if the system is changing its own rules, isn't that incredibly dangerous? What if it just decides, I'm going to turn off the firewall because I'm bored?
That is always the fear with self-modifying systems. But in OHID, every time the system updates its weights, every single time it learns something new and adjusts itself, that update is an event that gets written to the ledger.
So you can audit the learning process itself?
You can see the entire history of its education. You can literally see a chart that says, on February 12th, the system became 5% more paranoid about outbound traffic from this server. Resilience becomes a measurable, recorded process.
Okay, we've covered the tech. And honestly, it is impressive, if a little sci-fi. But technology doesn't exist in a vacuum. You have to sell it.
Right.
And this is where our deep dive takes a hard left turn out of computer science and into pure business strategy. The source material details this rollout plan for the 916.
Sacramento, California.
This baffled me when I first read it. You have this futuristic universal trust fabric. Why on earth would you launch it in Sacramento? Why not San Francisco? Why not Silicon Valley, where people actually like weird, new, futuristic tech?
The strategy document is brutally honest about this. They have this concept they call short trust distances.
Trust distance, define that for me.
It's a sociological concept. It's basically, how far do I have to travel metaphorically to trust you? In Silicon Valley, the trust distance is huge because there's so much noise, so much hype.
Everyone has a startup. Everyone has a revolutionary AI.
It's a low-trust environment because of the constant churn and overpromising. Too many scammers, too many vaporware pitch decks.
Okay, so how is Sacramento different?
Sacramento's different. It's a government town. It's filled with NGOs, state agencies, healthcare providers. It's a smaller, tighter community. If you solve a real problem for one director of a nonprofit, they're going to tell their friend who runs a state agency down the street.
The word of mouth travels faster.
The trust distance is short because the community is interconnected and, frankly, more pragmatic. The notes use a great phrase. Less hype, more seriousness.
Sacramento doesn't want to be disrupted. They just want to pass their compliance audits and keep their funding.
Exactly. They have real, boring problems that need solving.
So let's look at that first target audience, NGOs, non-governmental organizations. These are folks, saving whales or feeding the homeless. They usually have an IT budget of approximately $0. How do you sell them a universal trust fabric?
You don't sell them the tech, you sell them survival. The strategy here is really smart. It outlines these small lunch and learns.
5 to 15 people. And no sales decks.
No sales decks, no PowerPoint. That's bold.
So what's the pitch?
The pitch is very specific and targeted. How an NGO proves trust without a SOC.
A SOC being a security operations center.
Right, a room full of expensive analysts watching screens 24/7. An NGO can never, ever afford that.
Okay, let's role play this for a second. I am an NGO director. I have 3 employees, a shared laptop, and a GoFundMe page. I'm terrified of ransomware, and my big donors are starting to ask if their data is safe with me. You're the OH salesperson. What do you say?
I sit down with you, probably over a sandwich, and I say, look, I know you can't afford a security team, but you absolutely need to prove to your donors that you aren't being negligent. This software, it acts as your automated witness.
An automated witness. I like that.
It doesn't replace an IT guy, but it proves that you are following the rules that you set for yourself.
Yeah.
And at the end of the year, it generates a bronze tier audit report that you can hand directly to your board, and it costs a fraction of what you'd pay a consultant for a single afternoon.
You're not selling me technology. You're selling me peace of mind. You're selling me the ability to answer that donor's question without lying.
Exactly. I'm not selling ED 25519 keys or Xyber Logik. I am selling auditor-grade confidence in a box.
Speaking of auditors, the strategy for them is even more fascinating. It talks about bringing them a physical trust binder.
This is pure psychology, and it's brilliant. Auditors are professional skeptics. Your job, their entire purpose, is to find what you did wrong.
Right.
If you walk into a room with an auditor and say, my system is perfect and unassailable, they will destroy you. They will dig and dig until they find one tiny flaw just to prove you wrong.
So what does OI do instead?
They hand the auditor this physical binder and a script that essentially says, here is our attempt at building auditable controls. We're not saying it's perfect. In fact, we want you to critique it. Please invite them to break it.
You're asking them for help. You're making them part of the team.
Yes. You completely flip the dynamic. Instead of being the adversary, the auditor becomes the collaborator. Oh, you found a potential gap in our incident replay logic. Thank you. That's incredibly valuable feedback. Let's log that. You're validating their expertise.
By asking them to find flaws, you're actually building an ally who feels personally invested in the system's success.
It's manipulative, but it's brilliant. It's social engineering applied to the world of compliance.
It is. Now, once you hook these NGOs and auditors, there's a very specific onboarding checklist. And phase 0 really caught my eye, pre-onboarding, explicitly confirming out-of-scope items.
This is the liability shield. This is so important. Before anyone signs anything, they explicitly state, we do not provide SOC services, we do not do live monitoring, we do not do incident response.
But wait a minute. If I get hacked and I have OHID installed, isn't OHID supposed to help me?
No. And this is the crucial distinction they have to make. OHID is trust governance. It is not security operations.
Give me an analogy.
Okay, if your house catches on fire, OHID is not the fire department. OHID is the insurance adjuster who shows up the next day to document that you had smoke detectors installed and that the sprinklers turned on when they were supposed to.
Okay, so if I call the OHID support line screaming, I'm being hacked right now, what do they say?
They say, call the police. And don't worry, we're recording this entire event for the evidence package later.
That is a vital distinction. If you don't make that crystal clear up front, you're going to have some very, very angry customers when things inevitably go wrong.
Which is why it is phase 0. Before you even sign a contract, you have to initial a box that says you understand the difference between the firefighter and the notary.
The notary. I like that. Okay, let's talk about that auditor grade promise. We keep throwing around terms like SOC2 and NIST. For the listener who hasn't had the pleasure of suffering through a SOC2 audit, can you explain why this is such a nightmare for companies?
A SOC2 audit is basically a root canal for a business. It's painful, it's long, it's expensive. You have to prove hundreds of different controls.
Like what?
Things like, do you have a process to revoke access when an employee quits? Or do you encrypt company laptops? And usually, proving this involves taking hundreds and hundreds of screenshots.
You're kidding. Screenshots.
I am not kidding. I have sat in audit meetings where we spent days taking screenshots of user lists in our HR system to prove that Bob was removed on the date we said he was. It is manual, it's tedious, and it's static. It's proof from one moment in time.
So how does OID fix the screenshot hell?
By mapping the software's features directly to the specific SOC2 controls. The source material has this whole Appendix A that just draws a straight line from one to the other.
Give me an example.
Okay. SOC2 has a control, CC 1.2, which is all about the integrity of the system. It asks, do you have a process to ensure data integrity?
And normally I'd show a screenshot of a policy document.
Right. With OHID, you just point to its coalition council and quorum panel features. You say, we don't need a screenshot. Here's the permanent cryptographic log of the quorum voting on that data change.
Okay, what about another one? CC 7.4 incident resolution.
Instead of forwarding a chain of emails and a screenshot of a closed help desk ticket saying, I fixed it.
You just point them to the mission replay.
You point them to the mission replay and say, here is the DVR footage of the entire resolution process, from detection to closure.
It automates the evidence gathering. It makes the evidence alive and interactive instead of dead and static.
And it packages all of this into what they call the bronze tier compliance export. It's specifically designed for NGOs. It includes the identity governance, the immutable audit trail, and the incident replay.
But what does it exclude?
It excludes the really expensive stuff that an NGO doesn't need, like continuous penetration testing or a live SOC team. It gives a board of directors confidence without the crippling cost of an enterprise-grade security team.
There's also a management assertion mentioned in the notes, a pre-written letter by the founder, Emmanuel Kali-Uju. What's that about?
That's a legal requirement for an audit. At the end, management has to formally assert, in writing, we, the management, believe our controls are designed and operating effectively.
So OHID just gives you the letter.
It provides a pre-written, lawyer-approved version of that assertion. It basically says, the system's design inherently includes the necessary controls for identity and evidence governance. It's another way of reducing friction.
And there's even a script for talking to the auditor. Verbatim.
Yes.
Yeah.
It's hilarious, but also practical. It tells the user to say, and I'm quoting here, the system demonstrates a complete control and evidence lifecycle. Its architecture clearly supports continuous assurance.
That sounds like a robot.
It sounds like an auditor. It's using their language. It signals to the auditor, I understand your world. I know the secret handshake. It puts them at ease immediately.
Okay, this is fascinating. I want to go back to the deep tech for a minute. Part 5 of our outline is about something called TVCP.
Threat Vector Containment Proofs.
It sounds very military. What is it?
It's the kill confirmation. When you say a security incident is resolved, how do you actually prove it's over?
Usually the IT guy just closes the ticket and says all clear.
Right. Ticket closed is asserted trust. TVCP is verified trust. The protocol described in the source material involves using the command line, the terminal, to generate a mathematical proof that the threat is gone.
Okay, so how does it work? It mentions step 1, ledger identification.
First, you find the unique hash of the bad event on the ledger. You get the unique fingerprint of the hack.
Then step 2, Xyber Logik. Okay, we glazed over this earlier and we have to come back to it. Xyber Logik.
Yes.
I know chirality is a chemistry term. It means handedness, right? Like your left hand and your right hand are mirror images of each other, but you can't stack them perfectly.
Exactly. A molecule is chiral if it cannot be superposed on its mirror image. Thalidomide is the famous tragic example of this. One-handed version cured morning sickness, but its mirror image caused horrific birth defects. Same atoms, just a different spatial arrangement.
How on earth does that apply to server logs and security?
It's a brilliant metaphor for data consistency across a distributed system. In OHID, chiral logic is a process that checks for mirror image consistency across multiple secure nodes.
So what does that mean?
Let's say you have node A and node B. In a healthy system, they should be perfect mirrors of the truth. If a hacker gets into node A and alters the log to hide their tracks, the chirality breaks. The mirror image no longer matches.
The reflection is distorted. So the system detects that discrepancy between the two nodes.
It detects that the handedness of the data has flipped. It mathematically proves that the view from the inner daemon matches the view from the outer haven. If they don't match, the containment proof fails. It means something is still wrong.
That is a really deep concept. Okay, step 3 is SBOM mapping.
SBOM, that's a software bill of materials. It's basically the ingredients list for your code. So the system checks. Okay, we resolved the incident that was caused by a vulnerability in, say, log4j version 2.14. Did we actually update the library to the patch version? It links the event hash to the specific software module that was involved.
So it proves you fixed the root cause, not just the symptom.
Exactly. And finally, step 4, symbolic signature retrieval. This is the final digital receipt. It's a single, compact, cryptographic signature that serves as verifiable proof. It mathematically states, this threat, represented by hash X, was neutralized by this action, represented by hash Y, and its containment was verified by this chiral logic check, represented by hash Z.
And this is all done via an admin protocol, with commands like cmd ledger and cmd chiral.
Right, and that's an important distinction. The user sees the pretty 3D map and the mission replay. The admin goes into the terminal and interacts with the raw underlying math.
It gives the admin a sense of control, of power.
It gamifies the audit process. It makes them feel like they aren't just clicking buttons on a dashboard. They are directly querying the fabric of truth itself.
Okay, we've hyped this up a lot. We have to be realistic. What are the limitations here? What can this thing not do?
We touched on this before, but it really bears repeating. It is not an intrusion detection system. It will not stop a zero-day attack in real time.
It is not a shield, it is a camera.
Perfect. That's exactly right.
Yeah.
Also, the current demo that we're analyzing is client-side only. It's using local storage in your browser. It is a simulation.
So it's not ready to run a Fortune 500 company's backend tomorrow.
Not even close. It lacks the actual back-end distributed workflow orchestration. It's a proof of concept for the cryptographic and governance models.
So if a skeptical auditor asks, this is great, but why doesn't OHID stop the intrusion in the first place? What's the answer?
The document provides a scripted response for this exact question. The answer is, that responsibility remains with the user entity. OHIDs exist to make trust decisions inspectable and provable.
You pass the buck, you throw it right back to the user. My job is to be the notary and not the security guard.
Exactly. It's about setting clear boundaries of responsibility.
So what's the future then? The sources mention a section on planned evolutions.
Right. The next logical steps. First, they need to move to a persistent append-only ledger, a real database, not the browser's local storage.
Get it out of the simulation stage.
Exactly. Then they want to implement SigStore for real key management.
SigStore is a big deal in the open source world right now. Why does that matter here?
Because managing those little 8255 Norton keys is hard. If you lose your private key, you lose your identity and you can't sign anything. It's a huge operational headache.
Okay.
SigStore is an open source project backed by the Linux Foundation that makes key management much easier and more transparent. It often uses ephemeral, short-lived keys that are tied to your existing identity, like your company email. It solves the I lost my password problem for high-security cryptography.
And they also want to do a SOC2 type I audit on themselves.
Yes, eating their own dog food. You can't credibly sell auditor-grade compliance as a service if you aren't compliant yourself. That's table stakes.
And geographically, what's the plan?
It's a classic land and expand strategy. First, win Sacramento. Win the 916. Battle test the product in the sales pitch in that smaller, more serious market.
And then?
Then, once it's hardened, move to the Bay Area. Then down to Southern California. Then eventually, all 50 states.
World domination, starting with a single lunch and learn for a nonprofit in Sacramento.
It's a solid, pragmatic strategy. Don't try to boil the ocean. Boil a single cup of tea first and make sure you do it perfectly.
So let's try to wrap this all up. We've talked about the trust crisis. We've talked about this universal trust fabric, the outer walls of the haven and the inner watcher, the daemon. We've talked about the weird, cool, and sometimes baffling tech like Xyber Logik and generative AI evidence forges. And we've talked about the very human strategy of selling peace of mind to small nonprofits. What's the final synthesis here? What does this all mean?
I think OHID represents a maturity model for the entire software industry. For decades, we've been in this mode of compliance is a blocked weekend.
The annual fire drill.
The annual fire drill.
Yeah.
You know, that one panic-filled weekend a year when the auditors are coming and everyone stays late printing out screenshots and digging through old emails.
It's reactive. It's painful.
It's awful. The goal here is to move from that world to a world of compliance as a continuous coded fabric, where compliance isn't something you do once a year. It's just something that it's woven directly into the code itself.
It should be like the background radiation of the company. Always on, always present.
Exactly. It becomes an intrinsic property of the system, not an external process you bolt on at the end.
And here's the thought that's been sticking with me since we started reading these notes. It's a little provocative.
Let's hear it.
If we can cryptographically prove the why behind every single decision, using that explainable AI and that Xyber Logik, does the role of the human auditor eventually disappear?
That is the big provocative question, isn't it? Today, auditors are forensic accountants. They follow the paper trail, they check the checklists. But if the math can prove the process was followed, do we still need the person with the clipboard?
The sources mention a symbolic verifier tool designed for mathematically inclined auditors. That phrase stuck with me.
I think the auditor of the future isn't an accountant. I think they're a coder. They're a forensic logic explorer.
Forensic logic explorer. I want that on my business card right now.
It suggests a future where auditing is code, not checklists. Where truth is something you calculate, not something you argue about in a conference room based on conflicting screenshots.
And that ties everything back to the very beginning, to that concept of trust distances. If the math works, the distance between us, the trust distance, shrinks to almost zero.
Right.
I don't need to know you personally. I don't need to like you. I don't need to have a beer with you to trust that your system is behaving as promised. I just need to verify your proof.
And that changes everything. It allows for global, high-stakes cooperation without requiring personal intimacy or reputation. It's trust at scale.
It really does. So for everyone listening, as you go about your week, I want you to think about your own trust distances. Who do you trust and why? Is it because of a handshake? A reputation? A PDF they sent you?
Or do you have the receipts?
Or do you have the receipts? And if you had to prove your own security posture right now, if I walked into your office with a clipboard and asked, "Are you secure?" Could you prove it with a click, or would you need a month of panic and screenshots?
Something to mull over.
Absolutely. Thanks for diving deep with us today into the OA Universal Trust Fabric. It's a dense, dense topic, but one that might just reshape how we think about digital truth. We'll catch you on the next deep dive.
Stay secure.